Okay, now let us look at more example. In example 2 on page 115, okay, page 115, example 2, right, example 2. In example 2, you want to find a pi2, a plane called pi2 that passes through 2 points A and B and is parallel to a vector 2i minus j. So you can imagine that a plane may be, okay, allow me to draw a plane like this. So you got a point A and B, and then it is parallel to another vector 2 minus 1 0. So let me draw the vector parallel to this plane as like that. Okay, be very careful. No, I really do not mean that this vector which is parallel to the plane lies on the plane. I'm just drawing it to show you that it is parallel to the required plane. So maybe you can draw a diagram that's like this. Got a point AB, got point AB. So if this is the plane, there's a point A and this point B, right? This AB and this is a plane. And then this vector 2 minus 1 0, it is parallel to the plane. It could be like this, or it could be lying on the plane, or it could be below the plane. It really doesn't matter, right? Parallel to the plane does not mean that it must be lying on the plane. It could be above or even below, right? So the scenario given to us is that of a pi2, a plane pi2, with this information. So to find the equation of the plane, once again, it is vector r, the position vector of the generic point on the plane. You need a first vector, lambda, second, and then the third. How do we get the first vector? First vector represents the position vector of a point on the plane. So for this question, actually, I have obviously two choices. I could use the point 0, 1, minus 3. That is actually the position vector of A. Could I have used 1, 2, minus 4? Yes, of course. I could actually have written down pi2 with the first vector 1, 2, minus 4. I could have done the same thing. And then for the second vector, so okay, once again, you want to realize that you could have many choices. For the second vector, I need a vector that is parallel to the plane. So an obvious choice is already given in the question. I could use this. How about another vector that is parallel to the plane pi2, but make sure that it is not parallel to this vector 2 minus 1 0. What would be a good choice? An obvious choice for this could have been the vector AB itself, the vector AB. You are given a point A, you are given a point B, so the vector AB would serve as a good choice. So the vector AB, if you do a calculation, right, is OB minus OA. Right. Let me make a remark. This is, I'm using the vector AB for this purpose. Right. AB is just OB minus OA. So I could again use it for the second version. So here we are, the equation of pi2. In fact, you see here that there are two possibilities, 1 and 2. They are equivalent forms of the same plane pi2. So let's look at the third example, example 3. In example 3, you are told of a plane pi3. Okay, this is pi2, this is pi2. Okay, pi2. Now you're talking about a third plane pi3. Allow me to draw a plane like just, the shape pi3. In this example, you're told that it passes through 3 points. They didn't give the names for these points. They just pass through. They just say that it passes through 3 points. The first point is 2, 2, minus 2. So maybe I call this 2, 2, minus 2. And this is 2, minus 1, 0. And third one is 3, 0, minus 1. So now you have a plane that passes through three points. You must be very careful. When I wrote this vector down, you must be always reminded, you must remind yourself that when I write these 3 points down, like this vector 2, 2, minus 2, right? It means like this, no? Maybe this point is on the plane here, it's like that. 2, 2, minus 2 is actually a vector that's like this. A vector that's like this, okay? Like this, right? 2, 2, minus 2. And then the 3, 0, minus 1, and the 2, minus 1, 0. Right? So must bear in mind that actually these position vectors of these points take reference from origin, maybe somewhere below. Okay, now we are ready to write down the equation of this plane pi 3. Again, first vector, second vector, and then the third vector. Let me write carefully. Once again, the first vector, right? The first vector represents a point on the plane. In this case, I have actually more choices. I could write this vector as this, or this, or this. So I'll just arbitrarily take 2, 2, minus 2. Okay, I want to stress once again, this first vector could have been this, or could have been this. It doesn't matter. Next, I need a vector that is parallel to the plane pi 3. A convenient choice. A convenient choice for this vector that is parallel to pi 3 would have been this vector. How do you get this vector? Again, like what you did just now for AB, you take this minus this, and this gives me 1 minus 2, 1. And now I need another vector that's parallel to pi 3. This could be a good choice. And this minus this would be 0, minus 3, and 2. And there we are, the equation of the plane pi 3.